The air we normally breathe exerts an absolute pressure of 1 atmosphere. At this pressure, air supports combustion readily. That is to say, it contains oxygen sufficient in amount not only for burning, but for sustenance of life as well. How much oxygen is in the air can be approximated by this simple experiment. As the burning candle uses up the oxygen within the inverted container, the water rises to take its place. When the flame goes out, the water level reaches the 4/5 mark, proof that about 1/5 of the air is oxygen. The remaining 4/5 of the air's volume is nitrogen. Its absolute pressure is now 1 atmosphere, because the rising water compressed the nitrogen until its pressure equaled that of the outside air. But when this volume of nitrogen fills the entire container, as it did at the start of the experiment, its pressure is only 8/10 of an atmosphere. Since the nitrogen in air exerts a pressure of 8/10 of an atmosphere, and air a pressure of 1 atmosphere, the difference, 2/10 of an atmosphere, is the pressure exerted by oxygen. These values are called partial pressures. These are the symbols for nitrogen and oxygen. The gases in air exert pressure because they are composed of billions upon billions of infinitesimally small particles, called molecules, which are always in motion. Each time a molecule strikes the container, it exerts a force or pressure against it. The pressure we read on this gauge is a measure of the total force exerted by all the molecules that strike the container at any instant. 1/5 of these molecules are oxygen molecules. Therefore, the pressure they exert is 1/5 of the total pressure, or 1/5 times 1 atmosphere, namely 2/10 of an atmosphere. Since 4/5 of the molecules are nitrogen molecules, the pressure they exert is 4/5 of the total pressure. In this instance, 4/5 times 1 atmosphere. That is 8/10 of an atmosphere. From this, you can see that the partial pressure of each gas in air is obtained by taking the part each gas is of the total volume and multiplying it by the total pressure. Now, let's compress the air volume to 1/2, so the total pressure becomes 2 atmospheres, as you would expect from Boyle's law. Since 1/5 of this reduced volume is still oxygen, and 4/5 of it nitrogen, their partial pressures now become 4/10 of an atmosphere and 1 6/10 atmospheres. Changing the total pressure of air, or any other mixture of gases, changes the partial pressure of each gas in the mixture. But here's another way to change the partial pressure of a gas. The number of oxygen molecules is now only 1/10 of the total number, or in other words, its volume is 1/10 of the total volume. Therefore, the partial pressure of oxygen now becomes 1/10 times the total pressure, here 1 atmosphere, or a value of 1/10 of an atmosphere.